primarily a question and answer show. So if any of you out there would like to ask questions.
Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hello everyone, my name is Ryan Boyd.
And I'm Michael Manicherry.
And today we're here live from Campus London, in London, the United Kingdom, away from our home base of San Francisco, to talk with you about what's been exciting this week in the land of BigQuery. So this week we've actually done a lot of things. We've been out amongst the community, talking with the community, and gone to the Strata conference and some other events. But the real important thing, which we're here to talk with you about today around the world, is the launch that happened this week. We had a major launch for BigQuery, I think our largest launch probably since we went general availability, and that was on JSON support, nested and repeated support, and other improvements to BigQuery imports, which make it a lot easier for developers to use BigQuery. So we want to talk with you about some of those things. Not going into the presentation quite yet. We're just going to have a little bit of discussion on what we've been up to this week. That started off this week with the Strata conference. So on Monday, we went to the Strata London conference, and this is one of the premier big data conferences run by O'Reilly. And I actually gave a talk on BigQuery at Strata, and it went over really, really well. I only think I had a short 20 minutes, I believe.
It was a lot to pack in a short time.
It was a lot to pack in a short time, but we announced a lot of these new features at the Strata conference a few hours before they went live on our blogs based out of Mountain View. It was really exciting talking with all the developers. I heard afterwards the audience was abuzz and chatting amongst themselves about my query of 1 terabyte of data, running regular expressions on 13 billion rows in I think 23 seconds is what it took during that talk. And so there was a lot of buzz and energy around BigQuery as a product, and it was super exciting to talk with all those developers. We also did an office hours, and had a number of people stop by with various use cases, from travel agencies to marketing analytics firms. A lot of people stopping by and chatting with us about how they are currently using BigQuery or how they're planning on using BigQuery. And it was great to hear this stuff. If you're not out at one of these events with us, feel free to send that information to us online on Google+. Let us know how you're using BigQuery. It's just really fascinating for us to hear all the different use cases that you guys are using BigQuery for. And I'm trying to think what else at Strata conference.
Yeah,
we
did the data science meetup as well.
Yeah, we had the London Big Data Science meetup where we got to talk about BigQuery to their audience. That was a very short 5-minute talk, which we basically crammed our 50-minute talk into 20 minutes for the main Strata conference, and then moved it down to 5 minutes for the data science meetup.
Yeah, that was a very well attended talk, and we'd say we'd be back sometime to talk to them again.
Yeah,
it's
exactly. We plan to keep on coming out here to the UK to talk with developers. Do you want to talk, Michael, about some of the other stuff outside the conference?
So yeah, we did a little tour of some of the incubators around. One was Tech Hub Manchester, which is opening soon, and I got to meet with some of the startups there, some of the people in Manchester who are doing really good work around big data in the big data area. I met with a business intelligence startup who's interested in using BigQuery to have 100% cloud-based enterprise analytics software. This is a very small team, and it just goes to show what you can do with BigQuery. It's so powerful, and how fast you can develop. Yeah.
Their original plan was just to use a relational database that they were familiar with, but then they heard about BigQuery, and you could just see the excitement in their face, about the amount of data that could be crunched with BigQuery.
We always say it enables you to do things that you couldn't do before, and I think that was the theme of some of the startups that I visited. I also talked to several social media analytics startups, and these are also small 2-3 person teams who are thinking about using BigQuery to do some of the data crunching and data mining that it takes to really get value out of social media. And we also talked to some ISVs. We talked to a software vendor nearby that was using BigQuery in an end-to-end pipeline. using some of our partner tools, such as Talend for ETL and for transformation of data, and QlikView, which is another one of our partners for visualization of BigQuery query results. It was pretty exciting to see people putting these technologies together and building these pipelines.
Absolutely.
Cool stuff.
And we're actually out here with a bunch of the other folks from our cloud team, some folks from App Engine and folks from Compute Engine, and we've all talked to a bunch of startups. I actually dived back into my old world of working on Google Apps to talk with a number of folks who are doing some innovative things around Google Apps too. So it was all around a very exciting event or series of events around the UK, and I think we should emphasize that you said Manchester, but Manchester's a little bit outside of London, but it's exciting to really see the energy that's happening throughout the UK.
Yeah.
It's not just in London as we might have expected coming into this.
Yeah, it's all over. I was really impressed with all the startups and incubators I visited. I thought it was great. And there's a really big scene around, well, not just big data, but startups in general, London, Manchester, all over the UK. It's pretty impressive.
Yeah, so hopefully we'll actually come out here more to London and the UK areas in general, and hear more of this and see more of this. I think the data science meetup group invited us to come back and we give a fuller length talk, and we'd love to do that. So really exciting, and we're headed off tonight to Sydney, actually, and we're headed out to Australia to do a similar type of tour with a bunch of incubators and startups, and we're excited about that as well. And I'm trying to think of what's all in our tour here, but we're meeting with Google developer groups. We did a Google developer group in London. I think there's 8 events basically we're packing into 2 weeks. So it's great to be out there amongst the community, hearing what everyone's up to. And I actually, today's my birthday too, so...
Happy birthday, Ryan.
So I get to actually go celebrate my birthday. We're headed to Singapore. I think we have a 6-hour layover in Singapore, so we're going to get out and celebrate my birthday. If you want to come hunt us down in Singapore and celebrate my birthday with me, drop me a line. And I think we're going to a crab restaurant or something.
For the few hours we're there before we get back on the plane.
Exactly.
Sounds good.
But so, all around having a good time, but also hearing a lot about what developers are up to. So now let's talk about the real business instead of talking about our party.
Up to a terabyte of data at once. We've also, so a terabyte of data in one load job, which is an enormous amount of data. And also, individual files can be up to 100 gigabytes per file, depending on what type of file it is. So this is a lot of data. So Ryan, you were doing some testing on this earlier. And
yeah, actually, one of the big things about the 100 gigabyte per file is that's actually uncompressed files. So uncompressed files we can actually shard and kind of do parallel ingestion on a lot better than compressed files. Happy to chat with you about the reasons behind that, in another venue. But so 100 gigabytes of uncompressed files. And the real important thing is that you're actually able to send all your files in at once, and we just kind of queue them up for ingestion, and this makes it much easier for a developer to code against. So previously what you had is you had to make sure there were only, I think, 2 ingestion jobs per minute that you were sending in for the entire project. And this meant you really had to queue up your jobs and send them to us. Do a little sleeping, do a little for loops, and queue them up.
Put the responsibility on the developer, but we want to help you out.
So we're trying to really make this easier and put the responsibility on us to allow you to ingest a lot of data really quickly. So I've been playing around with this, and I've been able to ingest a lot of data. So previously I had 3 terabytes of data that I was trying to load in, and that 3 terabytes of data, I think, at absolute optimum, was it 12 hours, I think, or something like that. I believe it's 12 hours.
Many hours to get that much data in.
At absolute optimum speed, 12 hours. And in reality, it took a little bit longer because I didn't shard it perfectly and that sort of thing. But now I've actually taken, sorry, I missed the bullet point here on that, but I've actually taken that data that 3 terabytes of data and loaded it in 36 minutes into BigQuery. And because BigQuery doesn't actually build any indexes, BigQuery embraces the concept of a full table scan, which we've heard. There's actually some comments from Strata Conference about how embracing the concept of a full table scan gave some DBAs some heart palpitations.
Yeah, people gasped at the London GDD when I said that too. Like,
Yeah,
what?
exactly. So all you DBAs out there, please don't get heart palpitations. But we embrace the concept of full table scan, and so once you're able to load this 3 terabytes of data in, and in my example in 36 minutes, you can actually immediately start querying it. And that's about a 20x improvement over what it was before this week in terms of how quickly you can start querying your data. So really, really awesome for developers. Check it out if you have a large amount of data. It makes it a lot easier.
Good stuff. So let's talk about one of my favorite subjects, and getting App Engine data store data into BigQuery.
Before we dive into this, I do want to mention that we do have a Google Moderator. So for those of you that are watching this in your Google Plus stream, head over to developers.google.com/live and click on this event, and you'll see embedded in that page a Google Moderator that you can ask any questions that you have as you're listening to this event. And we'll visit that moderator at the end of this event and just go through some of those questions that you have. We're not doing a live hangout here today, but we are answering a lot of the questions after we have our little pontificating here. We're gonna answer a lot of those questions that you have either about these features or about BigQuery in general. And sorry for the interruption.
Oh,
Michael,
yeah, no
but
problem. So one of my favorite subjects is getting App Engine data store data into BigQuery. Combining these two technologies to have a high availability data store.
We're still jet lagged.
It's still jet lagged, and putting that data into Google BigQuery. If you've seen my Google I/O talk about this, you know we also have some documentation on our website. But now it's even easier to get App Engine data store data into BigQuery. We've launched a new trusted tester program of a new feature to put data store admin backup data into BigQuery. So let's just give you a little look at that. If you enable the App Engine data store admin function, there's a backup feature which lets you dump data store data into Google Cloud Storage. And now you can kick off BigQuery ingestion jobs on those data store data backups. This is a trusted tester program, so we're actually getting people to sign up now if you're interested. Just go to this link right here. It's a Google short link, QHTS capital H to get there. Or look for it on Ryan's recent blog post on the Google Developers blog. There's a link to the trusted tester program as well. We're really excited to see what people do with this and how you feel about it. So yeah, try it out.
So yeah, I mean, this actually shows how you can take data from a sort of high availability read-write data store like App Engine and bring it into BigQuery for analysis. So the data store is great if you need to maintain your kind of point of record for your data, high availability writes, and quick lookups of your data when things match keys and indexes and that sort of thing. But then load it into BigQuery for doing that aggregate analysis that things like Datastore aren't really as fast at doing. If you're trying to do an aggregate analysis on Datastore, you might have to use, say, App Engine MapReduce or something like that to really loop through all of your records and do your analysis. And that same thing holds true for other online databases, like NoSQL type style, document style databases. And we've actually talked with some of those folks, outside of Google at some of these events. At the Angel Hack event that we were at a couple weeks ago, we talked with the Firebase folks about doing this style of, basically get data out of Firebase and into BigQuery for analysis in a similar way that we're doing with App Engine.
Right.
And it'll be fantastic to have that level of integration. I believe, Michael, you were actually doing some experiments too, and you're planning on doing some MongoDB work.
Yeah, I was playing with MongoDB. I know a lot of web devs use MongoDB, and I think it's a good synergy between the two technologies, right? Use MongoDB for the kind of web interface backend and stick that data into BigQuery.
Synergy,
What?
Michael?
Did I say synergy? No, impossible.
Michael.
So
Anyway.
we'll synergize on this later.
Yeah, that sounds great, Michael. Anyway, the word synergy seems to come up in some business meetings, and Michael and I as engineers kind of laugh at it now and then. So it should be fantastic. So we can do it with App Engine today. Sign up for the Trusted Tester program. We're interested to know what your real business use cases are what types of value you're looking to get out of the data that you currently are storing in App Engine. And then, later on, we'll definitely be exploring some of these other NoSQL databases and document stores and figure out how we can get those integrated into BigQuery. If you guys have ideas, or if you have open source projects, definitely let us know what you guys are building. There's been actually a number of open source projects around BigQuery recently.
Yeah, definitely. There's like Ruby libraries. There are people doing logs into BigQuery. So a good place to follow this, what we're doing, is the Google Cloud Developers Plus page, or follow us on our private pages as well, and we will share some of these technologies with you.
And we're actually thinking about an upcoming hangout here, upcoming Google Developers Live session to talk about a lot of the open source efforts around BigQuery and what some other developers are doing. And maybe we can even invite some of those developers to the
sounds great.
Google Developers Live. So look forward to that, and let us know in the meantime what you're doing. So preparing your data. We just want to talk a little bit about, we talked about JSON and nested repeated as one of the things that we launched, I believe, on October 1st at the beginning of this week. And we just wanted to compare the different styles of data. Sometimes it's helpful to see it in sort of a graphic form, what the different styles of data looks like, and how you can work with it in BigQuery. So, typically a lot of our developers are familiar with relational databases. So this is a relational database schema where you have two separate tables, and you've sort of done normalization, which you're taught a lot in college database classes, to basically separate out the data so that for instance, if you have people here and each person has maybe lived in multiple cities, that you basically only have one definitive record per person, and then you have separate records for the cities that they've lived in, and you link the two up on a key. And that's really useful if you are trying to maintain consistency in a database environment, which is often a read-write database environment, and you want to make sure that you have perfect consistency. But you don't necessarily need that relational schema when you're trying to do large-scale aggregate analysis. And in fact, at times it's a lot faster to do large-scale aggregate analysis when you don't have that relational schema. So BigQuery has always taught you to do sort of a denormalized form where you take and make every single one of the rows, it's essentially a join, and you're doing a pre-join on your data when you're loading it into BigQuery. And you could represent that in a CSV format quite well. That denormalized form worked well in a CSV format. And that's the primary data format that BigQuery did support previously, and the only format we supported previously. But we've now looked and said, all right, well, what about JSON as a data format? And we can represent the data that you would represent in a CSV in a JSON object fairly easily. It looks a little heavier weight as you see here, because you're repeating the names of the fields over and over again. But as soon as you compress this data, it compresses down pretty small. We did use a new line delimited JSON format, and I want to stress that. You can see the \ns at the end of each of these lines. In reality, this would only be 2 lines of text, but on the slide, it's a lot easier to communicate it as it is here. And the new line delimited format allows us to really efficiently do things like parallel ingestion of the data that you're putting into the JSON format. But you can see here we've just basically taken that CSV format and put it into JSON. It's a little more expressive, a little easier to read, but doesn't add a huge amount of value other than potentially supporting some existing JSON based document stores and that sort of thing. But that's not all we've done. What we've done that adds a lot of value is giving you the ability to do nested data. So you can see here we went from sort of the normalized form to the denormalized form, and now we've given you the ability to represent structure in your data through nested and repeated values. And that structure really helps make it much easier for people who are looking at your data, developing against your data, and also as you're loading your data to kind of understand the underlying structure of your data. It really, in terms of the actual querying support that it provides, We can jump into the queries here a little bit later, but the queries aren't that much more expressive. You're not allowed to, or able to do that many more different things with the nested data, but it makes it a lot easier to understand and a lot easier to read, and basically represents how humans think a lot better in sort of an object-oriented, nested format. So you can see what that might look here for our table of people versus where they lived, various cities that they lived in. And then we support that now in JSON and be able to express that data in JSON format. And you can see here, this represents something like a birth record in this particular record here. And a birth record, it's one of our example data sets, the CDC birth statistics data. And you have, each baby born in the U.S. represents a row of that data. And in here, you have the states that the mother has lived in. The baby was born in 1979. The mother's lived in 3 different states. That's showing kind of the repeated structure of BigQuery. And then in terms of the nested and repeated structure, we have the health scores here. So they take a score, a measurement of a baby's health, after they're born, a couple minutes after they're born, maybe 10 minutes after they're born. Back in 1979, maybe they only took 2 measurements. So you would have the time at 5 minutes and the time at 10 minutes and what the baby's health was at each of those times. But let's say, nowadays they want to start collecting additional measurements. You can use the same schema and just add an additional time as you load new records into BigQuery. So it's really powerful in a way that allows you to structure your data a lot better, makes it a lot more readable and a lot more workable when you're writing your queries. So let's give you a few examples of queries here. Here's one example of querying nested and repeated data, a very simple example where we can say that the mother substance used dot alcohol equals true. So you could have a bunch of different substance used properties. I probably shouldn't go through the whole list of various substances that a mother could use that would affect the health of their baby. But mother substance used dot alcohol here equals true. And it, really that dot syntax allows you to kind of just express what the nested value is. And then where you get a little bit more complicated is when you're actually, complicated might not be the right term. Where you're able to be a little bit more expressive here is when you're trying to look at the nested data. And for instance, in this case, we're trying to figure out the average number of states a mother has lived in before giving birth to their child. And maybe you want to correlate that versus the health scores or the substances used or something.
And this is an interesting query, too, because the amount of states a mother has lived in could be a variable between records, right? So you could have somebody could be living in 5 states over their lifetime, maybe 2 states in another one.
Yeah, exactly. And you're trying to figure out kind of what the average number is. And that's what this within statement, within record, can give you a count.
Right.
And then you can do an aggregate on the outside of that as a super select of the sub-select statement here and get the average number of states that a mother had lived in.
So it's a very natural way to model the data. If this was in a flat record, it would just be a lot of repeated values over and over in the records.
Yeah, exactly. So I mean, it really allows you to repeat your data a lot less, and the underlying storage is a lot less when you have these nested repeated records. It's kind of ironic that repeated records allow you to repeat your data a lot less. But anyway. During the ingestion process, basically, you don't have to repeat the values for every single row as you flatten out the data. So, super valuable. And I think that this release really represents what we're trying to do with BigQuery, trying to make Google's underlying technologies available to you a lot easier to use than even some of the functionality that Google has internally. We're kind of adding that layer of ease on top of it for developers to be able to get their data in quickly in a format that they're accustomed to using with other NoSQL databases and other document stores and using elsewhere on the web in various APIs, the JSON format, and in the nested repeated structure that's a lot easier for developers to understand and then eventually query on. So I think that's really kind of sums up this release, as it just makes it a lot easier for developers to import data in a structure they understand and then query upon it. Anything else before we head off to the office hours?
No, let's do it. Let's check out what people are asking.
All right, so we're gonna ask questions from the audience, but You can express these questions over in Google Moderator. Again, just go to developers.google.com/live and click on the event here today, and you'll see a moderator embedded there. You can ask your questions. I think there's already some questions over there, so we're going to head over and check out on my browser here. Check out what questions there are. If I can learn how to operate my computer. It's always a challenge for me. So let's see here. Here's our moderator. So it looks like we have 5 questions from 6 people, and we'll just go through the, let's see here, does running queries. So let's go through the top to bottom here.
All right.
So you want to talk about the first question?
So this one here?
Yeah.
So does running queries with the unions on lots of tables affect the performance in terms of the time it takes to return the query result? So what this question is referring to is it's possible to run queries over tables with the same schema by doing a union query. Basically listing the table names in the query, running the query off over multiple tables at once.
Because oftentimes you'll actually shard your data in BigQuery. So if you for instance, I was looking at the Wikipedia page views, and I sharded that data. It's huge amounts of data. I sharded that data by month. So I could look and only embrace the full table scan on a month of data at a time, because often you only need to actually query the most recent month or something like that. So you'll shard your data, but then at times you do want to query over many months of data. And actually the 13 billion rows thing that I talked about was querying over many months of data in a union query like this talks about.
Yeah, definitely. By the way, for more information about sharding and table design, we have Ryan and I have written a new ingestion cookbook on our website, which provides best practices for data ingestion and schemas and sharding and things like that. To get back to this question, because of the design of BigQuery, actually there's a very negligible performance hit when you do these kind of things. Actually, the queries are returned very quickly, and that's due to the kind of distributed design of BigQuery. So you shouldn't see any performance hit when you run over multiple tables.
Yeah, if you look at one of our Google I/O video that I did, along with one of the core engineers on the BigQuery backend, we actually explain a lot of the underlying BigQuery structure and how it processes queries. So if you're a true query geek, true database geek, you might want to check that out. And you can see how each leaf node only processes a small chunk of data. It really doesn't matter what table that chunk of data is coming from. It doesn't change the performance characteristics. So the next one here, I guess I'll take this. And the data I'm dealing with is all time series data, and all the queries are time based. Will queries become more expensive as the size of the database increases? Is it a good idea to shard the database? Actually, this is quite relevant. Shard the database into monthly/biweekly tables to optimize costs. And the short answer is yes. So yes, it is helpful to shard the database, both for performance as well as for the cost. So it really depends on what types of queries that you're going to run. Are you running queries over all of your data usually? Or are you running queries just over a specific part of your data? Most people with time-based data, like I was saying earlier, just kind of oftentimes are just running queries over the last week or the last month. We even have people, some of our developers, that are sharding their data by hour because that's the type of access that they often need, is just looking at it on an hourly by hourly basis. And then you can even do things, I believe we have a way that you can express that the table should expire. So as your data gets old and you don't actually need to have data maybe from 5 years ago, you can automatically expire those tables as it goes on. So that's very helpful. And sharding, because we are embracing the concept of the full table scan, you're basically charged for the size of all the columns that you're querying times the number of rows that are in your table. And it's that complete table because we're doing the full table scan each time. So shard your data definitely if you're often doing queries that are over just a segment or sub part of your overall data.
These are really good questions, by the way.
Yeah, absolutely.
So it says, the next question is...
That's the one we just answered.
We answered that one. According to the BigQuery website, we are charged on the data process in each column selected in the query. What exactly does data process mean? Is this the amount of data being accessed to return a data set? Well, it's the amount of data being accessed to return your query result. So that, yes, that is how we charge. This is actually a very economical way to charge, because if you only select a certain set of columns to return your query result, you're only charged for the columns that the query touches, not the rest of the columns in your table. So that makes the queries as economical as possible.
And actually, I mean, from a performance perspective as well, we store this data in a column-based format. So we're only actually reading data off of disk that represents the columns that you're accessing. So this, basically the way that we're charging you directly maps onto our underlying costs and basically the time that it takes to read that data off of disk. So that's kind of an important part of BigQuery, because most of our customers are actually not needing to query across every single one of the columns in their table. So the row-based structure doesn't work well for them. But the column-based structure of BigQuery does work well. And in terms of what exactly does data process mean, it's really just the number of bytes in the column, the columns that you're accessing. So the size of each of the columns times the number of rows that we talked about. And I think one more question here on quantile queries.
Sure.
You've done a little bit more of that, so why don't you answer?
Yeah, I'm really interested in this one. So quantile queries do not allow any kind of grouping by another column. Do you have plans to allow this in the future? And this person is going to group by medians and 99th percentile of the time. This is a really interesting question. So currently, BigQuery's quantile function merely buckets data into any number of buckets that you want, but doesn't allow for a further group by function. We've been talking about this. We don't have any news to report, but we're looking into ways to improve the quantile function to provide additional functionality, like grouping the buckets by a certain other value in another column. So that doesn't exist yet, but we're looking into it, and we're glad that you have some use cases for it. It's interesting to see that people are looking to BigQuery to do things like this. Another thing you can do, by the way, is you can take the result set and feed that into another program that does additional statistical analysis. It's easy to get the results back as a CSV form, where you can pipe that into something like R, into a data frame with R or some other statistical packages. So you can also do that. And
oftentimes for those statistical type queries, people will use the hash function in BigQuery to select a random subset of their data. So they'll select 1/10 of their data or 1/100th of their data, and that allows you to do those statistical analyses on what was big data, but you're selecting the random subset to do the analyses on. And then you can verify your results by then selecting a different random subset, et cetera. So what I'm going to do here is I'm going to quickly refresh, because I'm not sure if this is actually refreshing on us. So I'm going to quickly refresh the screen here, and we'll see if there's any other questions that you guys have put into the moderator here. And if there are any other questions, we'll answer them. If not, it doesn't look like there are any other questions. So maybe we should thank you all for joining our show here today. And I do want to say that these types of questions provide great value for us to understand what you're thinking about and us to understand your feature requests. So although, for instance, we don't support what was just asked about the quantile functions that people are looking for, just asking them here today allows us to know that you're looking for that type of functionality and allows us to prioritize it better in our upcoming roadmap. So thank you. My name is Ryan Boyd.
And I'm Michael Minicheri.
And this is the Ryan and Michael Show, or the
Michael and Ryan Show. Live from London.
Take care.